Today we're going to be talking about complex numbers. Principal square root of a negative number. If a is a positive real number, then the principal square root of a negative number, negative a, is the imaginary number I square root of a. That is, the square root of negative a is equal to I square root of a. Then let a equal 1. Then square root of negative 1 is equal to I square root of 1, which is equal to I. So if I equals negative square root of 1, then I squared equals negative 1, I cubed equals negative I, and I to the fourth equals 1. Examples. Square root of negative 5 is I square root of 5. Negative 16, well 16 is a perfect square, so I can take the 4 out, and then I can also bring the I out. So it is 4I. And same thing with negative 1. 1 is a perfect square, so I can bring that out, and I can bring the I with it, so it's just going to be 1/2 I. Next is negative square root of 72. Well, we can take a perfect square out of that, which is, the perfect square is 36, so that's going to be 6. I can bring the I out, and that's going to leave me with the square root of 2. Given I raised to a power, divide the power by 4. The remainder is what used to determine the value. In order to be simplified, all answers must have I raised to a power of 1 or 0. Examples. I to the 9th is I. I to the 14th is negative 1. I to the 44th is I to the 39th is negative I. Again, we divided each one of the exponents by 4 and then counted through to how many were left. Okay, write the I before the radical but after the rational number. So that would be, examples, 3I square root of 2 or I square root of 7. Now you'll see it sometimes the other way, but this is the most common way it's seen. A complex number is a number of the form a plus bi, where a and b are real numbers and I is equal to the square root of negative 1. The number a is the real part of a plus bi, and b is the imaginary part. The complex number system, and you can look it over. It's just for your information, you don't need to copy it down. Okay, to simplify imaginary numbers, rewrite the square root of negative 1 as I, simplify the remaining radical. Commutative, associative, and distributive properties hold. Complex number, standard form, a plus bi, where a is the real part, bi is the imaginary part, and b is a real number. Okay, we're going to write complex numbers in standard form. This is going to be 3 plus 4i. We've already discussed how to simplify the square root. Okay, the next one is negative 4 times negative 1, because that's what I squared is, plus 2i. So that becomes 4 plus 2i. Okay, adding and subtracting complex numbers. To add or subtract complex numbers, combine the real parts and combine the imaginary parts. So here we're going to add, so 7 plus 5 is 12, and 3i minus 4i is minus I. Next one. Since we have a negative number, we have to distribute, or a minus, we have to distribute that. That makes this one minus, and that makes this one plus. So that's 3 minus 5 is negative 2. 4i plus 2i is plus 6i. For two complex numbers to be equal, the real parts must be equal, and the imaginary parts must be equal. Multiplying complex numbers. Multiplication with complex numbers is just like multiplying with polynomials. Remember to put square roots of negative numbers into terms of I before simplifying. Okay, all we do is FOIL or double distribute, and we get 6 times 2 is 12. 6 times negative 3i is negative 18i. Negative 2i times 2 is negative 4i. And negative 2i times negative 3i is positive 6i squared. Now we start simplifying that. That becomes 12 minus 22i plus 6 times negative 1. Well, 12 and negative 6 is 6, so that's 6 minus 22i. And there's my final answer, completely simplified. Okay, let's look at our second one. We've got to square both of them first, so that's going to be 1 minus 4i plus 4i squared minus 1 plus 4i plus 4i squared. Okay, that's a minus sign in there, so in the second one we're going to have to change the signs. Minus, minus, minus. Okay, 1 minus 1 is 0. Negative 4i and negative 4i is negative 8i. And positive 4i squared and negative 4i squared is 0. So my answer is negative 8i. Okay, the next thing we want to do is find the conjugate and then multiply. Well, the conjugate just means I need something that I can multiply by this binomial so I can get rid of the I. So what I do is multiply by its conjugate, which is the same binomial except for the sign in the middle is going to be the opposite, which now gives me a difference of 2 squares. So I know that's difference of 2 squares, so that's 49 minus 144 I squared. Okay, that makes that 49 plus 144, because I know that I squared is negative 1. So then that gives me 193. I've gotten rid of my i's, and as you can see, I just have a real number. Okay, I'm going to do the same thing with the second one. Its conjugate is negative 3 minus the square root of 2i. Okay, when I multiply times its conjugate, again, that's a difference of 2 squares, so that's going to be 9 minus 2i squared. Well, again, we already know that I squared equals negative 1. So that's 9 plus 2, which is 11. Next, we're going to, this is the reason why we find the conjugate, is because we need to write the quotient. Okay, the first one is not a binomial, it's just a monomial. Well, that's going to be easy to get rid of. All I need to do is multiply times itself. So that's going to be 2i and 2i. So that's going to give us negative 28i over 4i squared. Well, we know that the numerator is going to stay the same. We simplify the denominator, that makes that negative 4. So that means my final answer is 7i. Okay, let's look at our last example. We see it has a denominator like the 2 in the previous sets of problems, where we need to get rid of the denominator that is a binomial. Well, we just multiply by its conjugate, which is 1 plus 2i. Okay, again, it's just like difference of two squares on the bottom. On the top, I have to FOIL, so that's going to be 6 plus 12i minus 7i minus 14i squared over 1 minus 4i squared. Okay, so on the top, I know this becomes -1, so that's going to be 6 plus 14, which is 20, and 12 minus 7, which is my plus 5i. All over, well, again, I know that I squared becomes -1, so that's going to be 1 plus 4, which is 5, which I can simplify this to 4 plus I, because the 5 can divide into the 20 and divide into the 5i. Thank you, that's it. Hope you have a great day and enjoy doing your work. Goodbye.